Hi, Peter and David. I hope you're both well.
Hi, Lily.
Lily.
Hi. So how about you talk about, so we've got our 3 approaches on consuming the course. So how about you speak about this one here of the content approach?
Thanks, Lily. Yeah, this is sort of maybe the more traditional of approaches in some ways, because it's where we sort of present the ideas and then we use case studies and examples to illustrate them. Peter, and you've been...
Yes, well, traditional in one sense, maybe, but I think an important difference is that a traditional textbook approach to statistics nearly always focuses on particular techniques. And I think what we're trying to do is to get away from that and look for some underlying concepts and principles of thinking like a statistician, which might be an extra tool that data scientists can use in addition to their existing skills.
Absolutely. It's sort of, in each case, we're trying to draw out a single key point, which might help, people to understand, and then help them to understand how this relates to them. And broadly, we've sort of categorized it into these sorts of 4 parts of definitions matter, data matters, variability matters, and interactions matter. And do you want to say a bit about that those ideas?
Yeah, I think definitions is something that really its importance can't be overemphasized. It's easy to think that different ways of collecting data will produce a number that has the same meaning, but it's simply not true. And it was very clear, for example, in the COVID epidemic, that different agencies were counting cases and deaths in different ways, and the numbers differ materially, and that matters. You have to be aware of that before you decide what you're going to do with your data. And that follows on actually to data matters. It follows that if you've got potentially a lot of data sets which are superficially measuring the same thing but have different inherent characteristics, it's not always advantageous to pool them. Just having more data per se doesn't necessarily produce a more precise analysis. The trick is being able to use multiple data sets in combination in a way which preserves the validity and honesty of your conclusions.
And of course, the key point is that those conclusions depend for a specific question.
Yes.
You can use the same data, and merging them could be appropriate in one case and not appropriate in another case.
Exactly.
Because your COVID examples, if you're wanting to compare the number of cases in one country to another country, different definitions means that they're not comparable. But they might be okay if you're wanting to look at trends and understand how things are changing over time, because the trends may be captured by the different definitions. It depends. So it really depends on your question.
Yeah, exactly. Yeah.
And then there's the variability. I mean, that's at the heart of everything, isn't it?
Yeah. Oh, absolutely. I mean, I would probably argue that variation is the fundamental concept of the statistics discipline, and it's understanding not just the overall variability in your data, but decomposing it into different sources of variability, some of which you may be able to do something about and others of which you can't. That's really very important.
Absolutely. And that's really the heart of, any data, is the fact that it's not going to give you the answer. You're going to have to understand how to deal with, how to disentangle that variability to get meaningful answers out of it.
Yeah. Yeah.
And I suppose one of the hardest parts around this, which we often find people misusing or misunderstanding, is the interactions piece.
Yeah, exactly. And that comes across every time somebody writes down a multiple regression formula and says, this and that and the other. And the implicit assumption often is that the effects of this, that, and the other are entirely independent of each other. Whereas in fact, nearly always we're looking at a complex system, and we need to understand the interrelationship amongst the different inputs to the system if we're really going to understand the outputs.
Absolutely. It's sort of, silver bullet solutions where everything is simple are actually pretty rare in the real world. Being able to accept and try and understand and study complexity, that sort of, this is what an interaction sort of is all about, and it's what we need.
That's right. But my sort of parting shot, if you like, on complexity is that a fundamental principle of statistical thinking is that you add complexity where you need to, and only when you need to. And that's it's a balancing act, and it's hard to get exactly right.
Absolutely. You want the simplest thing that actually captures what you need and answers
Correct.
your question.
Yeah.
No, that's a really good thing to finish on. And I hope people enjoy this way of consuming the content. Thank you, Peter. See you soon.
Thank you, David and Lily. Bye.